So let's start. You got a couple different things going on there. Let's start with the one that's called Review Sheet 5.1 to 5.4. In my packet, it's the last page, and I think mine is just like yours. So Review Sheet 5.1 to 5.4. And let's start with number 2. So somebody tell me, what problem do you want to do in number 2? There's 3 different equations there to solve. What one looks interesting?
A.
All right. Let's do A. Okay, notice the directions say to answer in radians. So we're going to make sure that when we get around to finally saying what x equals, that we've done it in radians. All right, who has a suggestion as to how we would start this?
Would you factor out sine?
I definitely would start by factoring, yep. So both terms have a sign in them, so we'll pull that sign out. And what will I have left when I pull that sign out?
2 cosine x minus 1.
Yep. Don't forget the 1, folks, when you pull that sign out. So now we'll set them both equal to 0, which is what we do every time we factor. And we're going to end up with either sine equaling 0 or cosine equaling 1/2. Now, what do we know about zeros? What is special about how we handle zeros?
We have to use the circle.
Exactly. So we're going to go to our handy-dandy unit circle. And we're going to look around the unit circle for a place where sine is 0. And we remember that sine is which letter?
What?
Mm-hmm. Who is talking? Is that you, Tyler? I can't tell. Okay, thanks. All right. So sine is y. Where is y 0? Well, it looks like y is 0 here and here. So the 2 answers that come out of that are 0 and pi. Remember, we are answering in radians. It would be 0 and 180 if we were in degrees. Now, where does the cosine equal 1/2? Well, I don't know. But I do know it's in which quadrants. Where would the cosine be a positive 1/2?
1 and 2.
Be careful. Certainly 1.
4.
Yep, gotta be 4. Remember, cosine is x. Cosine is x. And x is positive over here on the right side. Now, I need the cosine adjacent over hypotenuse to be 1/2. So this angle is, this side is √3, which makes this angle how big?
60 degrees.
It's a 60-degree angle. Now remember, that would be perfect if we were in degrees, but we're in radians. So 60 is what fraction of 180?
Pi/3.
Yes, it's 1/3 of 180. So our angle is pi/3. Now, your answer is the pi/3 in quadrant 1, which is pi/3. And the pi/3 in quadrant 4, which would be what? How big is that angle?
300.
Well, yes, in degrees, that would be a 300-degree angle. Absolutely. How much is that in radians?
5.
Exactly.
Oh,
it's 5. Isn't 3 300 5 times 60? So it's 5 pi over 3s. It's 2 pi minus pi over 3, or 5 pi over 3s. All right, good job, that one's done. All right, let's pick one from number 4. So Jacob, let's let somebody else pick this time. Who wants to pick from number 4? Okay, which one? B? Did you say B as in boy?
Yeah.
All right. So we're going to verify or prove that tan plus cotan equals secant times cosecant. Obviously, if the thing's provable, it's provable both directions. In other words, you can start here and end here, or you can start here and end here. My centuries of experience have taught me that if I have a choice between an add and a plus, or an add and a times, I should go with the add, because I think you know what's going to happen here. I'm going to change these, right, into fractions, and then I'm going to have to add those fractions, so I'll need to get a common denominator. So even though I don't know where it's going to take me, I at least have some work to do. So here we go. What's tangent?
Sine over cosine.
Okay. Yep, sine over cosine. Thank you so much. Plus, what's cotangent?
Cosine over sine.
Yep. Very good. Now I'm going to go ahead and get that common denominator. And that common denominator is cosine sine. So to get the denominators both to match, I'm going to have to multiply this one by sine, top and bottom. Now it matches the common denominator. This one by cosine, top and bottom. Now both denominators are exactly the same. They're exactly what I wanted. So my numerator is sine squared on this fraction plus cosine squared on that fraction. Uh-oh. What about that?
It equals 1.
It does. So I have 1 over cosine sine. Now, remember, anything is legal as long as it is the same as what you're starting with. So I don't always have the ability to split up a big fraction like that, but since it's multiplication, isn't 1 over cosine sine the same as 1 over cosine times 1 over sine? Aren't these two things the same thing? And then I have my secant, cosecant, which is exactly what I wanted to end up with. All right, does anybody have a question about that? All right. I want to pick, in number 5, I want to pick either A or B, and then we're going to do C. So which one do you want to do, 5A or B?
B.
All right. So we're going to do the tangent of 75. Now remember, you're going to have a note card, and the note card is going to have a formula on it that is going to allow you to handle the tangent of 45 plus 30. So if you haven't made your note card yet, get out your colored sheet if you have it, and find the formula for the tangent of an angle plus an angle. everybody find it? The formula says take the tangent of the first one plus the tangent of the second one over 1 minus the tangent of the first one, tangent of the second one. All right, now obviously if we were doing problem A or we were doing some other problem, we might be using different numbers and a different formula, but the strategy is the same. Whatever angle you have, you need to write it in terms of your special angles. And then use the appropriate formula. Now we need to start plugging in all these values. So for this problem, I am going to need the tangent of 45. So I'm going to draw my 45 over here. Now, if you have that memorized, that the tangent of 45 is 1, that's fine. You don't need to draw the picture. But if you don't have that memorized, then you probably need to draw your picture. All right, so there is a picture of 45 and 30. Those are the two angles that I am using. So the tangent of 45 is 1. The tangent of 30 is 1 over root 3, which is root 3 over 3. And then we have exactly the same thing in the bottom, the same two numbers, tan 45, tan 30. So when I multiply 1 times the tangent of 30, I just get that. Okay, everybody still with me? All right, what am I going to do with this mess?
Multiply by the conjugates.
I could, but I'm going to have a mess with fractions. So I would suggest that the first thing you do is multiply everything by 3. You don't have to. You can go straight to the conjugate if you want. But that means you're going to be foiling with a bunch of fractions. So it might be easier to get rid of the fractions first. So I'm going to multiply everything by 3. So now I have 3 plus root 3. Right, because those cancel. And 3 minus root 3. Now I'll use my conjugate. It'll be a little easier just with the arithmetic now. So the conjugate is 3 plus root 3. And now I'll just do a bunch of foiling. Writing down as much as I need to keep everything straight so I don't make careless mistakes. So I've written down everything. Remember that root 3 times root 3 is just 3. All right, now I'm going to start collecting like terms. So it looks like on the top I have 12 plus 6 root 3. And on the bottom I actually have some canceling, and it's just going to be 6. All right, what do you notice about that? Anything?
Can you take out a 6?
You sure can. Take out a 6 from everything. Remember, you can only take out a 6 if you can take it out of everything, and we can. So my answer is just going to be 2 plus root 3. All right, anybody have a question about that? There's a lot of arithmetic there. The only trigonometry is this first part right here.
So this is 4. So when tan 45 went 1, how do you get 1 minus square root 3 over 3 in the denominator? At the very beginning.
Okay, there's 1. That 1 is in the
but
formula.
Would it be 1 minus 1?
But it's
Then
1
tan 3?
times.
Oh, okay.
It's 1 times root 3 over 3.
Okay.
Okay, now I want to do 5C because it's a little bit different. 5C also uses a double angle identity that you need to have memorized. Does anyone have that memorized? Remember, we're memorizing the 2x or 2u or 2 theta, whatever they say on your sheet. There's 3 of them. What's the one for cosine?
Cosine squared x minus sine squared x.
Yep, cosine squared minus sine squared. Yep. Okay, so that's what we're going to find. Now, what do we know? We know that x is in quadrant 4. Read the directions, it tells you x is in 4. And we know the cosine is 4/5. So adjacent over hypotenuse is 4/5. So this is the given. Okay? Now, where should I go from here?
Pythagorean theorem.
Absolutely. We're kind of programmed to always fill in that third side, and we are in fact going to need it in our formula. So just be careful. The third side is going to work out to be 25 minus 16, or -3. Mark it negative, even though in this problem it won't matter. Sometimes it does. So what's cosine? Well, we knew that. Cosine's 4/5, right? And sine is -3/5, right, from my picture, opposite over hypotenuse. So 4/5 squared is 16/25 minus, please don't cancel these negatives. This one's going to get squared out. So it's still going to be minus 9/25. So the answer to the problem is 7/25. Okay? Anybody have a question about that? If you'd been asked for sine 2x, you would do everything exactly the same but use a different formula, right? Yeah. Okay. All right, let's look at number 7. And let's just randomly pick a couple. So we have sine 17 cosine 13 minus cosine 17 sine 13. Now, when you see this on your quest, you're either going to recognize the formula from something you have memorized, or you're going to recognize the formula from something on your note card. This one is not one you have to have memorized. What
sine
is
u minus?
Exactly. It's the sine of angle minus angle. That's exactly right. On your colored sheet, we called it U and V. It could be X and Y, P and Q, alpha, beta, doesn't matter. It's angle minus angle. And the two angles are 17 and 13. So this is the formula for the sine of 4. And that's simply what you write down. What is it the formula for? It's the formula for the sine of 4. All right, how about B? Cosine squared 19 minus sine squared 19. Now, when you're looking at these, kind of ignore the angles. They're not the important part right now. What formula is cosine squared minus sine squared?
Cosine 2x.
Exactly, that one's memorized. It's the cosine of twice the angle. Well, the angle is 19, so this is the formula for the cosine of 38. Is that all right? one more. And then we've been through everything that's on the quest, so we'll go through another set on a different sheet. One more. Let's go back to our equations in number 3, part 3, because here we'll need a calculator. So let's do letter B. Letter B. Tangent squared, this is in part 3, letter B. Tangent squared plus 4 tangent equals 0. And I'm going to change the directions because the entire quest is in radians. So let's go ahead and do this one in radians, even though it says degrees. Okay? All right, so here we go. Who has an idea for this one? Yoo-hoo!
Are we gonna divide
Oh, by what?
tan x?
Okay, we're not going to divide by tan x because we never, ever, ever do that. Never divide by a variable. But we are going to factor it out. Yeah.
Tan x plus 4.
Yes, we're going to factor it out. So we're going to accomplish the same thing as the dividing. We're just not going to break any laws. We're going to factor it out instead of dividing it out. So we're going to keep it in the problem, but we're just going to separate it over here. So then we can say that tangent equals 0 or tangent equals -4. Would you agree with that? Now, what do we know about zeros?
Circle.
Yep.
Yeah,
And
circle.
even though we're using our calculator, guys, we still need to have a picture in front of us. Because remember, our calculator will only give us one answer, and almost always there's going to be at least 2 that come out of each of these. So you need a picture. The picture we need for a 0 is the circle. Where on the circle is tangent 0? Now remember, tangent is y over x. So where around that circle, if you put the y over the x, will you get a 0?
0, 1.
So, right here? Is this what you're talking about?
Oh, my bad. It should be 1, 0.
Exactly. This is what we want because y over x here is good. Y over x here is not. So this is one answer. So 0 is going to be one answer. What's going to be another answer? Isn't pi going to be an answer? Okay. Now, where is the tangent negative? I need the tangent to be a negative number. Where does that happen? People, it's y over x. How do you get that to be a negative number? What has to be the case?
It's in quadrant.
One of them's in quadrant 4 for sure, because x is positive, but y is negative. Where else can the tangent be negative?
Quadrant 3.
Quadrant 3? What happens when you put y over x in quadrant 3?
Oh, it's positive.
Yep.
Sorry. 1, 2.
Quadrant 2, that's where it is. Just think about it, guys. It's not something you're going to memorize. It's very easy. Logic it out. Where do you have one positive and one negative? That's what you have to have if the tangent's going to be negative. Okay, now, the tangent is 4. So if I were to draw a picture of that, it would look like that. You don't need to do that. I did it so that you could see that is not a special angle. Would you agree with me? That's not a 30 or something like that. So I'm going to get my calculator out. I'm going to set it in radians because that's what my directions are. and that's what the directions will be on the quest. So I set it in radians, and now I'm going to find the angle whose tangent is 4. So I'm going to press second tangent 4. Now, personally, I don't put the negative in because sometimes that messes me up, particularly in a cosine problem. I've already identified where the tangent's negative, so I don't need the negative anymore. I'm going to type second tangent 4, and it's going to tell me how big my reference angle is. And that's what I really need to know. How big is my reference angle? So I typed in second tangent 4, and I got 1.33. Now, is 1.33 an answer? No. The answer, one of the answers, is going to be this purple angle. That's the angle in quadrant 2. And how will I find that angle? What will I have to do to my 1.33?
Turn it to radians, or you can subtract.
It's already in radians.
Oh, gosh, sorry. Take pi and subtract
Exactly.
minus 1.33.
Pi minus 1.33. Yep, that's exactly what I want to do. So pi minus 1.33, 1.81. So one of my answers, the purple one, is 1.81. If that were a degree measure, you take 180 minus it. Well, it's a radian measure, so we take pi minus it. Now, what about the green one? How am I going to find the big green angle?
Pi minus 1.33.
Yep, 2 pi minus 1.33. In degrees, it would be 360 minus that. But in radians, it's 2 pi. So 2 pi minus 1.33, 4.95. Don't forget, we got these 2 answers in the beginning, so we actually have 4 answers to this problem. 0 pi, and then the purple and the green.
I got a question.
Yep.
So when we're plugging in negative numbers into the calculator, will we never have to just put the negative in?
I don't.
I don't.
If I've always drawn my picture first, and I always draw my picture first. Okay?
Yeah.
All right, now let's find the sheet called Pretest 5154. And in my packet, it's the page right before the one we just did. It's called Pretest 5154. It's got problems on it exactly the same. And again, I'm going to pick out ones that are specific to our quest, because we're not taking a full test over this. Okay, so let's start with, we're going to do one from part 2. So somebody pick one from part 2, A, B, C, or D?
C.
C. Oh, okay. It's hard to know when you're just randomly picking. This is a really easy one. I'm going to get a different marker here. So doesn't it occur to you that maybe you'll change these into your fractions? And as soon as you do that, you've got a couple of fractions that need added together. So we'll get a common denominator. And can you see what's going to happen when I get my common denominator? I think I'm going to have what I need. So I'm going to multiply this one by cosine and this one by sine. So now my denominators match, and my numerator is going to be cosine plus sine. I've put answers to all these in Schoology, so if you want to practice some more and check your work, you can. All right, let's look at part 3. And let's start with, what about B, problem B? Again, we're going to change it into radians, the directions. We're going to do this in radians. What do we do with tangent squared minus 4 tangent minus 5?
You distribute it?
Factor it, you mean?
Factor, sorry, yeah.
Yep. No, that's fine. Factoring is distribution, that's right. So we're going to factor it. And how does it factor? 2 parentheses.
Minus 5 plus 1.
That sounds good to me. So tangent equals 5, or tangent equals -1. All right. 5 is not one of my special numbers, so I know for sure I'm going to need a calculator to do this. Where does the tangent equal a positive number?
Quadrant 1 and quadrant 3.
Yep. So I'm going to go to my calculator and I'm going to find the angle that has a tangent of 5. So second tangent 5. And in radians, that's 1.37. Now I'm going to get 2 answers out of this, quadrant 1 and quadrant 3. My quadrant 1 answer is 1.37. Would you agree with that? Since it's in quadrant 1, that's it. How am I going to find my quadrant 3 answer? I'll go all the way around here and then an extra 1.37. So how will I find that number?
Add pi.
Yep. So pi plus 1.37, which is 4.51. Now don't get too excited, we're not done yet. Now we need to find where the tangent is negative. Well, where will the tangent be negative? Guys, if it's positive in 1 and 3,
2 and 4.
then it's going to be negative in 2 and 4. Yep. Tangent is y over x. If it's negative, one of them's positive and one of them's negative. One angle has a tangent of 1. Well, that's actually one of our special ones, but if we're using a calculator, we'll say second tangent 1, and it's 0.79. .79 is not an answer this time. We need the red angle, which we'll find how. How will I calculate the red angle?
Pi minus 0.79.
Pi minus 0.79, which is 2.35. And then I need the green one, which is all the way around. So that one will be, how will I get that one? 2 pi minus 0.79. So that should come out to be 5.49, is that right? No, let me try that again. Yeah, 5.49. So there are the 4 answers to the problem. All right, anybody have a question about that one? All right, let's look at number 6. And let's do A and B for number 6. So we have the cosine of 75. We'll start with that one. What's going to be our strategy? Notice it says exact. So if you just press cosine 75 on your calculator, you get no points. How do we find the exact value? What are we going to have to do with our 75?
You're going to have to take 45 plus 30,
yep.
Like cosine.
Yep, or something. Now, 45 and 30 are the most obvious, but when we did this in our notes, we talked about that there are lots of ways you can get 75 degrees. It does not have to be 45 and 30, but those are certainly the easiest. So I don't want you to go out of your way trying to get wild and crazy. Just use the obvious ones, although there are others that will work. Okay, now we have a formula that helps us with this. So on your sheet, this is the cosine of u plus v. So the sheet says that's cosine 45 cosine 30 minus sine 45 sine 30. That's the formula straight off the sheet. You're going to put it on your note card. You're going to have your note card done for our next class. If you're going to use it, you got to have it. All right, so here we go. Now I have to start plugging in numbers for the 45 and the 30. So I'm going to draw them both right now. So I have them here. Draw my 45, 45, 90 and my 30, 60, 90 triangles. Okay. What's the cosine of 45? I'm going to start plugging all these numbers in now. What's the cosine of 45?
1 over radical 2.
I'm going to write that root 2 over 2 because I'm eventually going to have to rationalize it anyway, so I'll just do it right now, right off the bat. And isn't that the same as the sine of 45? They're exactly the same, the sine and cosine, so I'll go ahead and fill that one in. Now, what about the cosine of 30? What's the cosine of 30?
Root 3 over 2.
Perfect. And the sine of 30 is not the same. The sine of 30 is 1/2. So these are the ones, remember, we're going to multiply each piece, so we get root 6 over 4. Top times top, bottom times bottom. That's how we multiply fractions. Top times top, bottom times bottom. And then, since they have a common denominator, we're going to go ahead and write them as one fraction, even though we can't combine the root 6 and the root 2. This is the answer. They stay separate like that. But instead of having 2 separate fractions, we make one fraction. All right, anybody have a question about that one? All right, I want to do B also. B says find the tangent of 2A. So that's a memorized formula. Anybody have it memorized yet? Want to show off? What's the tangent of 2A?
2 tan x minus 1 minus tan squared x.
So it's 2 tan over 1 minus tan squared. Yeah, is that what you said? I couldn't quite understand. That's the formula. That's what you said. Good job. 2 tan over 1 minus tan squared. That's your double angle tangent. All right, let's draw a picture of what they told me. They told me that I'm in quadrant 2, and they told me that the secant is negative 5/3. Okay, what does that mean? If the secant is negative 5/3.
It's r over x.
So the cosine, yeah, would be negative 3/5. So it looks like that. Make sure you put the negative on the 3 and not on the 5. Remember, our hypotenuse is never negative. So even when it says negative 5/3, that's really 5 over negative 3. All right, now what do? That's the given. Now what?
Pythagorean theorem.
Yep. So 25 minus 9, that's going to be 4. And it actually will be positive because y is positive in quadrant 2. Okay. So we wrote down our formula. We wrote our picture. Now we're just going to plug in. So here we go. 2 times the tangent. The tangent is 4 over negative 3 over 1 minus the tangent squared. So I'm just going to my picture. The tangent is opposite over adjacent, and I'm just plugging that into my formula. So on the top, I have 2 over 1 times 4 over 3, so that gives me negative 8/3, top times top, bottom times bottom. And again, do not get cancel happy. These negatives don't cancel because that one's going to get squared. So it's still going to be 1 minus 16/9. Okay? Now, at this point, it does not make any difference how you simplify that. You're going to have to simplify that one way or the other. It makes no difference, so do whatever you're comfortable with. I'm going to multiply everything by 9 because then I don't have to worry about getting common denominators. If I multiply everything by 9, I'll end up with negative 24 on the top and 9 minus 16 on the bottom. So that's negative 24 over negative 7. So my answer is 24/7. You will get the same answer if you simplify this a different way. You do not have to simplify it that way. I think that's the fastest way. But if it doesn't make sense to you, don't do it. Do it however it makes sense to you. All right, any question about that? All right, let's look at part 4. And let's look at C, number C or letter C in part 4. It says 2 sine 111 cosine 111. Now remember, these ones that look like this, where you've got this expanded thing and you have to simplify it, you're either going to recognize the formula from your memory or you're going to recognize it on your note card. This one is from your memory because what is 2 sine cosine the formula for? 2 times sine times cosine.
Sine 2x?
Yep. Sine 2 times the angle. And the angle is 111. So this is a formula for the sine of 222. Remember, when you're trying to figure out the formula, don't worry about the angle. You can plug the angle in later. Look at what's happening in the formula. 2 sine cosine. That's the formula for sine 2 theta. All right, what about D? Sine 98 cosine 12 minus cosine 98 sine 12. That one is not memorized. That one's going to be on your note card. What's that one? That's the formula for what? Sine cosine minus cosine sine.
Sine U minus V.
Uh-huh. And your U and V are 98 and 12. So that's the formula for the sine of, what is that, 86?
How would you do E?
E, well, what's sine squared plus cosine squared?
1.
There you go. Doesn't matter what the angle is. Sine squared plus cosine squared is 1. Always. Okay, let's try, we'll try one more from this page. Let's try 3C. All right, and we're in radians now. We're in radians. All right, who's got a suggestion to get us started? Uh-oh. We're in trouble if we don't know how to get started. We got to get rid of that 2x. What's the cosine of 2x? Cosine squared minus sine squared. Now, what should we fix about this? This does not look very good. What should we fix about this?
Take out a sign.
Well, I would love to take out a sine, but I can't take it out of a cosine. What can I do, though, about that cosine squared? What do I know about cosine squared?
You can change it to 1 minus sine squared.
Yes, and why does it just make sense to do that?
You just make all the signs the same. And
Exactly.
Then go from that.
And then maybe I can factor, right? You can't factor when you got a mixture of like P's and Q's. You want to have all P's or all Q's. So we'll change cosine squared into 1 minus sine squared. All right, now we have a mess that we'll try to clean up here. So this is going to be negative 2 sine squared plus sine plus 1 if I add those together and put it in descending order. Somewhere in my life, I developed an aversion to having a negative x squared term. So I'm going to divide everything by -1. Perfectly legal, not necessary. It's necessary for me, but it's not necessary for everyone. I'm going to divide everything by a -1. And now, somebody said factor a little while ago. Now I'm ready to factor. Maybe, hopefully. So 2 sine and sine. That would give me my 2 sine squared. And then I really just need a 1 and a 1. That's all I can have on the end. And if I do a plus and a minus, that will make outsides be negative 2 sine and insides be 1 sine, which are what we want. So there's the factoring for that quadratic. So now I'll set them equal to 0. So sine x equals negative 1/2, or sine x equals 1. This one I'm going to do without a calculator because I can. Sometimes I can, sometimes I can't. On your quest, you'll answer exactly when possible. So it is not possible to answer these exactly, so that's what we'll do by hand. All right, where is the sign negative? Where is the sign negative?
2 and 4.
Let's rethink that.
Sorry, it's 1 and 3, or 1 and 2. See, now I'm just guessing.
What should you be thinking about? What variable is sine?
That's y over r, right?
So sine is y. R is always positive, so it's irrelevant in the conversation. Sine is y. Where is y negative?
3 and 4.
Yep. So down here I got a sine that's 1 over 2. What does that mean? Negative 1 over 2. What does that mean about that angle right there? How big is that angle if its sine is 1/2?
$30.
Yep. Now I am in radians, so 30 would be the correct degree answer. And if you really can't do it in radians, then 30 will have to be your answer. You won't get full credit for it, but that's better than nothing. That's a 30-degree angle. What is 30 in terms of radians?
Pi over 6.
Yes, because 30 is a 1/6 of 180. So we have, pi over 6 is not an answer. The answers are the pi over 6 that's in quadrant 3, and then the pi over 6 that's in quadrant 4. So, how do we find the red angle? What am I going to do to get the red angle that goes all the way to the pi line and then pi over 6 past that? Wouldn't that be pi plus pi over 6? Which is 7/6 pi. And then what about the green one? Isn't it all the way around except for the pi over 6 there? So that would be 2 pi minus pi over 6, which is 11 pi over 6. Oh, but don't get excited, we're not done. We still have this part to do. Now, keep in mind what Jacob said a minute ago about sine. He said it's y over r. If y over r is 1 over 1, then wouldn't that mean y and r are the same? And is that possible to draw a triangle where y and r are the same? Is that possible? No. So if it's not possible to draw this in a triangle, I'm going to draw it in a circle. Where does it happen that y is 1? I need y to be 1. I need sine to be 1. Where does that happen?
0, 1, and then 0, -1.
Okay, I need y to be 1. Where is y 1? Oh my gosh, guys. Y is the second coordinate, right? It's 1 right there at pi over 2. So your other answer is pi over 2. That's the only place where the sign is 1. Okay, well, I just noticed we're at the end of the period. And, okay, so we've gone through every problem on the quest at least twice. And you have a plethora of other review materials here, other problems available to you. For the quest preparation, just do the types that we have done. So there are other things on there, but I mean, if you're preparing just for the quest, those are the things you need to do. Okay? Anybody have any questions? All right, I'll see ya. Ellie, did you ever show up? I don't think Ellie ever showed up. All right, see you later. Have a great day.
Miss Vicky?
Yes.
Well, is like the quest just like as many questions as like a quiz or something, or
It's
how is that
six questions.
6 questions?
Mhm.
Okay, thank you.
Oh, shoot, I need to turn that off.